Hello and welcome to our Unit 8 notes for Algebra 2R. So this is our final exam review, and the focus of this unit was all on sequences and series. So first of all, let's talk about the difference between arithmetic and geometric sequences. An arithmetic sequence is a set of terms in a specific order having a common difference that we call D. An arithmetic sequence represents a linear function, and there are two formulas that you will need to know how to use when it comes to arithmetic sequences. This first guy right here is your explicit formula, which allows you to find any term. So like if you want to find the fifth term, you would just plug 5 in for n. And this one is on your reference sheet. This one, the recursive formula, which has two parts, is not on your reference sheet. So you need to memorize how to use that. So keep in mind for recursive, it is a sub n, so the next term equals the previous term plus whatever your common difference is, whether it's a positive common difference or a negative common difference. So arithmetic sequences are solely based on whatever the previous term was. All right, so given our first example here, it says given the sequence, write an explicit definition, a recursive definition, and then use one of the formulas to find a sub 20. All right, so first thing I'm noticing is my common difference would be -3 because it's going down by 3, and my first term is 50. So for an explicit formula, this is just a sub n equals a sub 1 plus n minus 1 times d, and then I just plug in what I got here. Use parentheses around the -3, otherwise it will look like subtract 3. And from there, if it doesn't tell you to simplify and put in standard form, that's a perfectly fine final answer. But again, in a multiple choice, you might not see that. You might see it simplified, so just be aware that you may have to distribute that -3 and simplify. Now, a recursive formula has two parts. You state your first term, which in this case is 50. And then if you want the next term of the sequence, you're going to take the previous term and do what with it? You're going to take away 3. And that's your recursive formula. So again, first guy was explicit, second guy was recursive. Now, if I want to find a sub 20, you're going to want to use your explicit formula because otherwise with recursive, you'd have to find the previous 19 terms to even have it work. So a sub 20 equals, if I go here, this would be 50 plus 20 minus 1 times -3, and then I can grab my calculator. So 50 plus 20 minus 1 times -3, and that gives me -7. And that would be your 20th term. Now, something else you can do to check yourself is actually look at this equation that you came up with, your explicit formula, and type it into y1 in your calculator. So instead of n, I'm going to plug in an x. And then I can go to my table of values, and you'll see that the first term is 50. The second term is 47, and so on and so forth. So that means my equation that I came up with is correct. And then I can actually double check my math here to see if a sub 20 is -7. And it is, so I did my math correctly. -7 would be the 20th term of that sequence. Quick little calculator hack here, guys. Let's say you want to quickly make it back to 0 in your table. If you hit second window, which brings up table set, there's something called table start. If I put 0 there and then go back to my table, now I'm back at 0. So just a little FYI, a little calculator hack there. All right, example 2, use the given recursive sequence to find the second term, third term, and fourth term. So I know the first term is 12, and this says if you want the next term of the sequence, take the previous term and add 7 to it. So that means a sub 2 is equal to a sub 1 plus 7, which is 19. If I want the third term, I'm going to take the previous term, which is 19, add 7 to it, and that would give me 26. If I want the fourth term, I'm going to take the previous term, add 7 to it, and that would give me 33. So notice how I'm always using the previous term to find the next term by adding the common difference. Common difference in this case was 7. The previous term is simply coming from where this a sub n minus 1 is. And that's how you read recursive sequences. All right, so let's move on down to the next section on geometric sequences. So a geometric sequence, geometric sequence is a set of terms in a specific order, each having a common ratio, which we call R. A geometric sequence will have features similar to an exponential function. Just like up above, explicit formulas allow you to find any term of a sequence. Recursive formulas are all based on the previous term. Additionally, again, explicit is on your reference sheet. Recursive needs to be memorized. So, given the sequence, write an explicit definition, a recursive definition, and then use one of the formulas to find a sub 8. So just like what we did up above. Now, in order to find your common ratio, you can always take a term and divide by its previous term. So in this case, my common ratio would be 60 divided by 300. Oopsies. Typed it in my calculator wrong. 60 divided by 300. And we get 0.2. So 0.2, you could also do 2/10, 1/5, anything mathematically equivalent to that. So I figured out R. My first term is 300. So for an explicit formula, this would be a sub n equals a sub 1 times R to the n minus 1, just by using that formula right there, just plugging in what I know. Recursive formula, again, has two parts. If you throw your a sub 1 in there, being 300, if you want the next term, you're going to take the previous term and multiply it by our common ratio, which we just found was 0.2. So if you follow exactly like how it's modeled in our formula here, the R goes in front. I tend to, with my students, just to keep it consistent with the formula up above, put the R after, because I just tend to find it's easier to remember that this is the same as this. You want the next term, take the previous term and multiply by something or add something, but either way is fine. Okay, so put this in front or switch it, doesn't matter. Now, just like with the explicit formula up above for arithmetic, I'm going to use that to help me determine the 8th term if my geometric. So if I want the 8th term, I'm going to use the explicit formula. So a sub 8 equals 300 times 0.2 to the 8 minus 1. Grab my calculator. So 8 minus 1 would be 7 if you want to just do that. And I get 0.00384. Let's see, is that a fraction? 12/3125. Either one of those is fine. Now, just like how I double-checked my arithmetic equation, explicit equation up above, I can do the same thing with my geometric. So let's see, if I plug this in, 300 times 0.2 to the x minus 1, and I go to my table of values. Oops, not the graph, second table. All right, there you're seeing the first term's 300, second term's 60, third term's 12, so that's matching, so that means my equation is correct. If I want to find the 8th term, I can go down and take a little peek, and there you go. That matches exactly what my math showed. All right, using the recursive sequence, we're going to find the second term, third term, and fourth term. So this says, if you want the next term of the sequence, take the previous term and multiply by 4. So a sub 2 would equal the previous term, which would be 2, times 4, which would be 8. If I want the next term, I'm going to take my previous term of 8, and again multiply by 4. That gives me 32. And if I want the fourth term, I'm going to take 32 and multiply by 4, which, if I go to my calculator, 32 times 4 would be 128. So again, in each of these, your common ratio is 4, so that's why you're seeing that match. And if you want the next term, you're taking the previous term and multiplying by that common ratio. All right, on to the next page. Finding the common difference or common ratio and using it to determine an explicit formula. So I got a couple little tips listed on the left here to find your arithmetic or geometric with examples listed. For an arithmetic sequence, you can calculate the slope of your terms, or just map it out like you're seeing down here and realize that you're just adding the same common difference of d every time, and then you could come up with a little equation for it. So instance, that would be 5 plus 1, 2, 3, 4d equals 17. Now, the slope method of solving this would be thinking about this as like the coordinate 2, 5. And this is the coordinate 6, 17, so 6 term 17, second term's 5, and then doing change in y over change in x. No matter what, when you solve, you'll end up with a common difference of 3. So again, the slope of an arithmetic sequence, so if you were to actually plot those points, they would have a slope of 3, which matches what the common difference is. All right, so given an arithmetic sequence where a sub 2 is negative 10 and a sub 5 is negative 4, determine an explicit formula for a sub n. So first of all, an explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. So things I'm going to need to find are the first term and the common difference. So if I know the second term is negative 10, and the fifth term is negative 4, I can use these to figure out the common difference by doing change in y, so negative 4 minus negative 10 over change in x. So I'm just doing slope here. Got a little double negative action going on, so that would leave me with a 6 over a 3, which is a common difference of 2. Now, from there, if I do map this out for a little bit, 1, 2, 3, here's your first term, here's your second, here's your third. You know that the second term is negative 10, and the common difference is a plus 2. So that means going forward, you would be adding 2, which would give you a negative 8, which means going backwards, you would subtract 2, which would give me a negative 12. And now I know my first term. So now that I know my first term and my common difference, my explicit formula is negative 12 plus n minus 1 times 2. Now let's double check that. If I go to my calculator and type that into y1, so negative 12 plus x minus 1 times 2, and go to my table. Okay, first term is negative 12, second term is negative 10, which is matching this, and the fifth term is negative 4, which is exactly what I was hoping for. Did not mean to rhyme, but it just happened. Now with geometric sequences, I always just map it out and count the number of skips. This will represent your exponent on r. So we know with the geometric sequence that you're just multiplying by a common difference of r every time. So if you know the second term is 10 and the fourth term is 15.625, I know to get from 10 to the next term, I would multiply by r, which would make this be 10r. Multiply by r again, and it would be 10r squared. That means 10r squared equals 15.625, and then I divide by 10, take the square root, and then technically you could have a positive or a negative for your geometric, for your common ratio there. So, given the geometric sequence where a sub 2 is 5 and a sub 6 is 0.3125, again, we're going to determine the explicit formula for a sub n, and this time it actually tells you assuming r is positive. So we're not going to have to worry about having a negative common ratio if we take the square root. So here we go. An explicit formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Map it out. 1, 2, 3, 4, 5, 6. Okay, so I know my second term is 5, and my sixth term is 0.3125. In geometric sequences, you're multiplying by r. So this next term would be 5r, this would be 5r squared, this would be 5r cubed, and this would be 5r to the fourth. So that means 5r to the fourth must be equivalent to 0.3125. Now let's solve. I'll divide both sides by 5. Grab my calculator. Okay, so I get 0.0625. And then I'll take the fourth root, or you could raise both sides to the 1/4 power, which is the exact same thing as taking the fourth root. So I'm going to take that guy, raise him to the 1/4, and I get 0.5. All right, so that means going forward, you're multiplying by 1/2, which means going backwards, you'd be multiplying by 2, so that means your first term must be 10. So putting it all together, a sub n equals 10 times r to the n minus 1, and that would be your equation. Now again, let me double check this. Go here, go to your y equals. I'm going to plug in 10 times 0.5 to the x minus 1 and go to my table of values. My second term is 5. That checks out. And my sixth term is 0.3125. So we're good to go. I did come up with the correct equation. All right, so moving on to the next section, we have summation notation. So this is with our sigma symbol, so that's a Greek letter for capital S. Oops, I have the highlighter on. The sum of a sequence is called a series, meaning you add up all the terms in the sequence to get a total. So what you guys are seeing is a summation notation, a sigma symbol, and they'll have a start value and an end value and some expression to plug into. So in order to evaluate this, the first thing I'll do is plug in 1 for n. Oops. Plus, then I'll go up to the next integer value. So that would be 2. Next integer value. Next. Until I get to 5. And I'm going to stop at 5 because that end value was 5. So again, I'm starting at 1 because it told me, and I'm ending at 5 because that's where it told me to end. And then I just evaluate. So this is 4 plus 8 plus 12 plus 16 plus 20. And then I'm going to grab my calculator. and I get 60. Okay, now next example, they're telling me to start at 2, so I'm going to plug that in, and then I'll come back to what this does at the end. All right, so I'm going to plug 2 in for n, next integer value, next integer value, and then I'm stopping because, again, the beginning was to start at 2, so that's what you saw me plug in. The end was to stop at 4. So just like what I did up above, but then on top of it, whatever this ends up being, it wants you to multiply by 2 at the end, okay? So this would be 2 times, this would be 3 squared, which would be 9. This is 4 squared, which is 16. And this is 5 squared, which is 25. Grab my calculator. 9 plus 16 plus 25 would be 50. And then times 2 would be 100. All right, last one in this section. I'm going to take 0 now and plug in for n. So he goes there. So this would be x minus 2 to the 0 plus x minus 2 to the first plus x minus 2 to the second. Again, I'm starting at 0, ending at 2. Now, anything to the 0 power is equal to 1, and anything to the first power is just himself. This last part, though, make sure you FOIL. So that would be plus x squared minus 4x plus 4. And if you're going to mess up that FOIL, I always say when in doubt, write it out, and then actually go through your FOIL. Now from there, it wants my answer in standard form. Whoops, I meant to highlight that. Whoop. Which means I need to combine my like terms and put it from highest degree to lowest. So my highest degree is x squared. It looks like I have negative 3 x's, and then I have 4 minus 2, which would be 2, plus 1, which would be 3. So x squared minus 3x plus 3. All right, last page of our summary notes. We have our geometric series formula. Now, this is on your reference sheet. Okay, so I'm going to write a little note. This is on your reference sheet. So you don't have to have that memorized. That's a weird S. Let me try this again. There we go. This is on your reference sheet. You need to know your first term, your common ratio, oops, not ratio, and n represents the number of terms that you would be adding together. So if I want to find the sum of the geometric series of the following sequence, okay, it's following geometric sequence, first thing I got to figure out is what the common ratio is. So remember, your ratio can be any numbers divided. So I could take 8 and divide him by 4, so a number divided by his previous, and that would give me a 2, which I think would be most obvious for you guys. It looks like we're doubling each time going forward. Your first term is 1/4 or 0.25, however you want to plug it in. And if I want to figure out n, that's just counting how many terms we're adding. So 1, 2, 3, 4, 5, 6, 7, 8 it looks like. So n would be 8. So now plugging into my formula, if I want the sum of the first 8 terms, I know the first term is 1/4. The common ratio is 2. Again, there's 8 terms. And then 1 minus 2 for my common ratio. And now I go to my calculator. So if I do alpha y equals, I can go ahead and do, I'm going to do decimals, 0.25 minus 0.25 times 2 to the 8th all over 1 minus 2. I like to use alpha y equals so that I don't mess up our order of operations in my calculator. Hit enter, and I get 63.75. All right, moving on to the next guy. The sum of a geometric series with 8 terms is 675. The common ratio is 2. Find the first term. So notice how in this scenario, you know the sum of the first 8 terms is 765. R is equal to 2. They want you to find the first term. One thing else I should list here, n is 8, which is why those are related. Okay, so now I just switched up what you're solving for, but it's still the same formula. So I'm going to plug 678 in for S sub n, or 670, oh my god, I can't even talk, 765 in for the sum. My first term, I don't know, so let's call him x. My common ratio is 2, and I know there's 8 terms. Now from there, I'm just going to clean this up a little bit. Don't know 2 to the 8th off the top of my head. Oops. 2 to the 8th. 2, 5, 6. And then 1 minus 2 is negative 1. Now, notice here, those are actually like terms. So if you do 1 minus 256, which is pretty obvious here, it's negative 255. Put this over 1 and cross multiply, you would have negative 765 equals negative 255x. Now I just have to divide. And I get x equals 3. Which means the first term of your sequence must be 3. So again, where I just highlighted is where people tend to forget that those are like terms, so I'm just combining that here. And then it's just cross multiply to solve. All right, next section is on mortgages. Do not fret. If they want to ask you a mortgage question on your exam, this would be given to you with what everything means. So just make sure you read carefully. Chloe and Chris have found a home for sale for $325,000. They can afford a 20% down payment. If they plan to take out a 30-year mortgage at 3.6% interest, find the total monthly payment. All right, so first of all, we got to figure out the loan size. So keep in mind, they're putting 20% down. So that means they're paying 20% up front, which means the loan size is going to make up 80% of what's left over of the house's value. So they still owe 80% on the house, essentially. So I am going to do 80% of 325,000. So 325,000 times 0.8. Oops, I forgot my multiplication. Times 0.8. And we end up with 2 6 and 4 zeros. Okay, so basically they still owe $260,000 on the house then. That's their loan size. Their recurring payment is actually what you're solving for. That's their monthly payment. Now, this interest rate is actually an annual interest rate. So anytime they talk about that in terms of houses. So in order to figure out my monthly interest rate, I'm going to take 0.036, because I'm putting that in decimal form, and then dividing him by 12. And that'll give me what I is. And that gives me 0.003. Okay, next is our number of payments. So they have a 30-year mortgage and they're paying monthly. So that would mean they need to make 360 total payments. So at this point, everybody, I have everything I need. I know the loan size is 260,000. So I'm plugging that in for A sub P. I don't know R. And then the rest of the formula is 1 minus, parentheses, 1 plus my monthly interest rate, raised to the negative 360 for n, all over, again, my monthly interest rate, just by following the formula on the left. So next thing I'm going to do is figure out what this whole mess is, because that's going to be some decimal. Okay, so I go to my calculator, alpha y equals, oopsies, alpha y equals, and I can start typing in 1 minus parentheses 1 plus 0.003 raised to the negative 360 all over 0.003. I'm just double checking I typed that in right, and I get some 219.95 number. So it's that times R equals 26000, 4 zeros. Okay, now in order to solve for R, you're just going to have to divide. I'm going to go up and copy paste that answer, and I get 1182. I'll do nearest cent, so and 8 cents. Now on a Regents, they would probably give you some sort of rounding direction there, like near cent or maybe nearest dollar, so just make sure you look out for that. All right, 2 more problems just to make sure we cover our bases. I know this is kind of a long video, so bear with me. Use the explicit formula to find how many terms are in a sequence and then calculate the sum of the series. Ooh, okay, so a lot of stuff going on here. First thing I got to notice is what kind of sequence is this? It looks like we are multiplying by 4 each time, which means it's a geometric sequence. So I'm going to write down my geometric sequence formula. Explicit formula, I should say. So a sub 1 times r to the n minus 1. Now, I know that my nth term is this right here. First, second, third, something happens in between, all the way up to n. So that means I'm going to plug this number in for a sub n because he is the term. I know my first term is 3 and my common ratio is 4. Your objective is to solve for n, which helps you determine what number term that is in the sequence. All right, so algebraically and using my explicit formula, what I can do first is divide by 3. So grabbing my calculator, 196608 divided by 3 would be 65536. Now, technically at this point, you know logs for final review. So there's actually a couple ways to do this. You could do log base answer equals power and then solve from there. So let me grab my calculator. Math, alpha, math, 4. And I'm going to go up and copy paste that. That works out nicely to an 8. So that means I must have 9 terms in the sequence. Now something else that you could be aware of, which we learned in our exponentials unit, so I'll kind of do this down here, is I can rewrite this with a common base of 4. So 4 to some power equals 65536. So if I go to my calculator and I just start like guessing here, 4 to the 7th, not big enough, 4 to the 8th, which kind of makes sense based on my log work right here. So 4 to the 8th, which is what this log is saying, 4 to what power gives you that, 4 to the 8th. Now that the bases are the same, solve the exponent, and you get 9. So I just showed you 2 algebraic ways to solve. Now, a third way to do this, which isn't algebraic, but it's a graphic check, is once you come up with your explicit formula, which is right here on the left, okay, I can go to my calculator, type in y equals 3 times 4 to the x minus 1, and then go to my table of values. So this is going to mimic what you're seeing. So 3, 12, 48, and, all the way up. So now I just got to find that missing term. So 196608. So if I scroll down, there he is, and that's the 9th term, which is why all my algebraic work makes sense. Now, this is a big problem. So I first found how many terms were in the sequence. Now I got to calculate the sum. Oh my goodness, this is a big problem. Ms. Costanzo put this in our review packet for us to do, so I'm going to blame her for this long problem, but it's a good problem, right? Okay, so this is like part 1 to this, so I apologize for the lack of space. Part 2, I'm just going to continue down here. Using my geometric series formula, S sub n, which actually would be the sum of the first 9 terms, would be a sub 1 minus a sub 1 times r to the n minus 1, so again, n is 9, all over our common ratio, which is 4, which again, oopsies, 1 minus 4. I was going to say, I have this memorized, and then I accidentally put that in the wrong place. It's just this formula up here. A sub 1 minus a sub 1 times r to the n minus 1 all over 1 minus r. And then I go to my calculator. So, second quits, alpha y equals, okay, 3 minus 3 times 4 raised to the 9 minus 1, which is 8, all over, and then I'll just simplify in my head, negative 3. And it looks like our sum ends up being 65535. All right, we're almost done, guys. I know we're nearing at 36 minutes. I didn't think that this would be this long, but there's just so much to show you guys. All right, so how many terms are there in a geometric series? If the first term is 2, the ratio is 3, and the sum of the series is 2, 4, 2. So this is actually very similar to what I did up above. Again, this is your formula. S sub n equals a sub 1 minus a sub 1 times r to the n all over 1 minus r. You don't have to have it memorized. It's on your reference sheet. I'm going to plug in what I know. 2, 4, 2 for the sum. Do I know the first term? No, yes, I do. It's 2. 2 minus 2. I know the common ratio is 3, but I don't know how many terms, so that's n. And then my bottom here would be 1 minus my common ratio, which is 3. So cleaning this up a little bit, this is 2, 4, 2 equals 2 minus 2 times 3 to the n all over negative 2. And then I would put this over 1 and then cross multiply from there. I'm going to delete this line. All right, so that leaves me with negative 484 equals 2 minus 2 times 3 to the n. I got rid of the fraction. Now I'll subtract 2. And then divide by negative 2. So this would be positive 243. Now again, just like how I did up above, I know logs, so I can do log base answer equals power. Go to my calculator. And I get 5. So that means there are 5 terms in that sequence. Whew, all right, 38 minutes. Imagine if we had to do that in class together. So lucky for you guys, you can rewatch this video as much as you need. You can rewind, watch it, as much as you need. All right, so hopefully this helped. It was a lot of info.